As we start discussing IP version 6 here, I'm going to be even blunter than I usually am. If you are scared of IP version 6, nervous about it, whatever euphemism, whatever word you want to use, you're not alone. I've seen anxiety before, especially with binary and subnetting, which you are way past now after taking this course. There's no reason for you to be anxious about it. And why? Because you know what's going on. That's the same thing it is with anxiety, really, in any field or any subject, anything you're studying. And especially with IP version 6, though, I've never seen anxiety this high. And people tend not to learn it until they absolutely have to. I'm actually putting together a separate IP version 6 course just to help people get over that anxiety. And you're getting several hours of that course actually right here, because that's what this section is all about. It's not just version 6 and learning it, but it's also just getting past your anxiety about it. Because here's one reason you need to do so, is that you need to do so. It's all around us today anyway. It's from your smartphone to your refrigerator. And even if you're not working directly with it today, one day you're going to be, as long as you took the initiative to learn it. Because as I mentioned, a lot of people have put off learning IP version 6, and I think it's because what you see on the bottom of your screen right now, it's the address format. We're going to talk about that in a moment. But even if version 6 doesn't impact your current career, you are limiting your future prospects if you're not strong with version 6. You really are. It's going to catch up with people sooner or later, and instead of being one of those that's learning it because you have to, you need to be one of those who's learning it because you want to and you're planning for the future. We're going to give you a strong foundation right here in this course. We've got, I don't know the exact time right now since we're just starting, but a couple of hours, I would guess, of labs here. We've got plenty of live labs here. It's not just theory. We're not just looking at the board, but we are going to at first because we need to dive into these addresses. And as I mentioned, I'm going to be really honest here, even more honest than I usually am. Listen, the first time I saw version 6 address, I practically freaked. I think part of it was because I was into the IE lab prep at the time. I was just like, oh, man, I got to do this. But let's face it, when you've been looking at IP addresses of, say, 129.14.12.200, and you're used to those, and you're used to subnetting them, and you're used to working with them and troubleshooting and etc. And somebody says, hey, we need to learn this version 6 stuff. And a typical IP address there is 1029.9183.81AE, 2 blocks of 0, 0AC1, 2143019B. You're just like, okay. See, personally, I thought before I ever saw version 6, I thought it would just be tacking 2 more octets onto version 4. How's that for honesty? Because that's what a lot of people thought. It's like, no, we're just extending it by, 2 blocks. So not only are we making the address much longer, but also we're throwing hex into the mix. And you're very familiar with hex by this point. If not, you need to go back and review your hex, because hex is very simple. You're not going to let that trip you up. But again, when you start throwing in these mysterious letters into an address, that starts making you a little bit nervous too. But again, just as with binary and subnetting, you might have been nervous before you started that. You weren't quite sure what was going on. You've seen a lot of different ways to do things. But when you just see how it all breaks down to ones and zeros, your anxiety goes away. You still got to practice it a lot to get really good at it, but the anxiety goes away. That's just a cloud. It's all anxiety is. It's just a mental cloud. Stops you from learning things. Once you're past the anxiety, everything else is gold. And that's exactly the way you're going to be with IP version 6. With that address, though, let's start talking about that, because as you can see on the board here, with that typical IP version 4 address and 6 address, version 6 isn't exactly just tacking 2 more octets onto a version 4 address. Now, another reason that I think people freak out when they see these addresses is, oh, I got to type all that stuff without making a mistake. Because a lot of people, of course, don't like typing to begin with, or, tell themselves they're not very good. And, of course, they have to be careful with numbers. Well, you will be happy to know there are some rules that will shorten these addresses a bit, and it is an extraordinarily good idea to be fluent with these rules for your CCENT and CCNA exams. The good news is the rules aren't complex. Believe it or not, we're coming up on something where there's no gray area, no exceptions. It is what it is. I am what I am. You don't have to worry about, in case it's the 13th of the month, I have to do it a different way. Zero compression and leading zero compression are about the most straightforward things you're ever going to run into in networking study. Now, first off, with zero compression, when you have consecutive blocks of zeros in an IPv6 address, you can represent all of them with a single set of colons. Now, obviously, you have to be careful with this on an exam. Say if you were shown a list of addresses and you're saying, which one of these are legal, which ones aren't. We have single colons throughout the address anyway. So you just have to be a little more careful and look for those sets of colons. Now, again, it doesn't matter if you have 2 fields of them or 8 fields of them, or if you want to call these blocks or quartets, whatever you want to. There's no one universal name for it, but just this one block of numbers, 1, 2, 3, 4, I tend to call it a block or a field. But if you have 2 fields of zeros or 8 fields, you can type 2 colons and that represents all of them. The key is that you can only perform the zero compression once in an IPv6 address. Now I've got an example for you there on the board. We have 4 blocks of zeros right in the middle of the address. Using zero compression, we represent those 4 blocks with 2 colons and wham, you are done. Now again, you have to be careful when you're scanning a list of IPv6 addresses for legality, whether it be a practice exam or the real thing, because we have single colons in there anyway. If you see 2 sets of colons in the same address, it's illegal. Period. No exceptions. You don't have to worry about day of the week it is, anything like that. We don't have the usual exceptions. There are none for that rule. Now there's another kind of zero compression that we can use called leading zero compression. With this one, we can drop leading zeros in any block, but each block must have at least one number remaining. And you're going to see exactly what I mean by this in just a moment. And again, this is leading zero compression, easy to remember because you're dropping the leading zeros in a block. And you can do this as many times as you like. Now, I've taken the address 1234 all zeros, 1234 all zeros, 1234 all zeros, 1234 0123. We have 4 different blocks there that have leading zeros. Now, the address could be written out as it is, or we could drop the leading zeros. And you see what I've done here with the first block of all zeros. I used leading zero compression and left 1 0. Remember, you can't have an empty block with leading zero compression. And I did the same thing with this block of all zeros and this block of all zeros. Then I have the block of 0, 1, 2, 3, and all I did was drop the leading zero. Again, I can do this as many times as I like. Now, one thing you do have to get used to, pardon me, with version 6 addressing is that there's never just one way to express an address unless it has no zeros in it, and that's pretty rare. Any leading zeros or a block of zeros. Both of these expressions are correct. It's just that one uses leading zero compression and the other does not. So that's a good thing to watch out for you on your exam as well. Also, and thankfully, using zero compression and leading zero compression is not mutually exclusive. You can use both in the same address, but again, you can only use zero compression once. You can see this next address, and what I did, I used zero compression to compress the 2 blocks of zeros there and represent them with a set of colons. And then I just did leading zero compression on each of the last 4 blocks. Just be careful, take your time with leading zero compression and zero compression, and you'll nail any question they give you on this. Now, I know what a lot of you were thinking when we started talking about zero compression, and that immediately was, why can't I use that more than once? Because that was the first thing I thought when I was learning this years ago. It's like, wham, why can't I use zero compression more than once if it's so effective? Well, there's a really good reason for that, and let's check out this example on the board. And you see that we've got 2 different areas where we could use zero compression. We could use zero compression on the 2nd and 3rd block and represent that with a set of colons, or we could use it on blocks 5, 6, and 7 and represent that with a single set of colons. Now this is an if. Please watch this. This is an if. If we were able to use zero compression more than once, we could compress the address like this. 1111, set of colons, 2222, set of colons, 3333. And life is beautiful, right? But what happens when the full address is needed? What happens when the address is re-expanded, if you will? Well, we know there are 8 blocks of numbers in an IPv6 address. Got that. But how would we know the number of blocks represented by each set of colons? You know, that full address could be this, where you have one block of all zeros and the second block and then 4 more later. Or it could be the 4 in the front, 2, 3, 4, and 5, and then block 7. Or it could be blocks 2, 3, and 4, and then 6 and 7. So if multiple uses of zero compression were legal, every one of these addresses could be represented by 1111 set of colons, 2222 set of colons, 3333, and none of them would actually be the original address. This is why using zero compression more than once in a version 6 address is illegal, because there wouldn't be any way to know exactly what the original address was, which of course would pretty much defeat the purpose of what we're doing. So that is why you can only use zero compression once in a version 6 address. Now here's a little something I call the trailing zero kaboom, a technical term I grant you, but you want to watch this one because it can kaboom points right off your exam score. When you're working with zero compression, it is really easy to fall for this. It's really easy to knock off some trailing zeros along with the full blocks of zeros like this. And you see what happens in block 3. I've got 3300 here, followed by 3 blocks that are candidates for zero compression, of course, and then 2 zeros in the beginning of block 7. That does not compress to 3-3 in that third block, because those are trailing zeros. And again, it's just really easy to do. You write this address on a paper and say, okay, I'm going to represent all these zeros with zero compression, but you couldn't do it. You can't compress trailing zeros. So the correct compression would be 1s, 2s, then 3300, then 2 colons representing those 3 blocks. Then you could drop the leading zeros out of this block and then go forward from there. That's another way to identify illegal version 6 addresses immediately, by the way. If you see multiple colon sets or zeros at the end of a block being compressed, then it is indeed illegal. Let's talk about one more thing here about decompressing while avoiding the bends. Decompressing a version 6 address, it's very simple. Just you have to keep that zero compression rule in mind. And here's an example. We have 2222, then 23 for the next block, A for the next block, then a set of colons, followed by BBCC, DDD, 342. So what we want to do is decompress this and say, what would we do here if we were asked, what is the full IP version 6 address that this address represents? And we're going to go over that at the very beginning of the next video. So if you didn't grab the piece of paper and a pencil, whatever you want to write with, go ahead and grab it now, because we're going to be doing a lot more of this as we go forward. And then go ahead and decompress this, and we'll see what the answer is at the beginning of the next video. See you there.